Hello. Today I'm going to be going over the OSI model and the TCP IP model, as well as their similarities and their differences. Alright, so what is the OSI model? Introduced in the 1980s, the OSI model, or the Open Systems Interconnection Model, is a theoretical framework made up of 7 different layers for determining what computer systems need to communicate over a network. The 7 layers of the OSI model are physical, data link, network, transport, session, presentation, and application. Each layer serves a specific purpose and is designed to only interact with the layers directly above and below it. The OSI model is helpful when you need to communicate networking information in a simple and understandable manner, such as specifying which layer a certain networking device operates at, or for communicating network problems clearly and efficiently to your team or others. The OSI model is great for troubleshooting because by isolating and assigning the problem to a specific layer, you may avoid dead leads and spend more time focusing on the areas that are most likely to be the issue. Okay, so the first layer of the OSI model is the physical layer. The physical layer deals with transmitting raw bits of data over a physical medium. This can be done through sending pulses of electricity through a copper wire or pulses of radio waves through an antenna. The next layer is the data link layer, which is actually made up of 2 sublayers, the logical link control and the media access control. Media access control deals with framing and physical addressing, while the logical link control, or the LLC, deals with error detection, flow control, and connection type. The networking layer handles routing and addressing. IP addresses allow for interconnecting different local networks to exchange information. Routers are layer 3 devices that handle determining routes and delivering packets to the correct address on the local network or across to other networks. The transport layer ensures that data gets across the networks efficiently, using segmentation and port numbers. Segmentation divides the information into smaller pieces, while port numbers allow the data to be handed to the correct application when it arrives on the machine. Next we have the session layer. The session layer manages communication and flow control between applications. Once devices are connected, a session is created. A checkpoint of the session can be created that allows for a recovery of the session if the connection is somehow terminated before the data transfer is completed. The next layer we have is the presentation layer. The presentation layer manages data translation and compression. This is where encryption and decryption or other processes occur to convert data to a usable format for the application layer. The next layer is the application layer. This is the interface between the network and end-user applications. This layer is for generating user input for the application to use and prepare the data to send across the network. What is the TCP/IP model? The TCP/IP model, or the Transmission Control Protocol Internet Protocol model, is the default method of communication used on the Internet and is supposed to be more of a practical framework rather than theoretical. Developed in the 1970s, the TCP/IP model is used to allow a network to achieve accurate transmission of data between systems. The TCP/IP model defines protocols such as TCP, IP, and UDP. The TCP/IP model is composed of 4 layers: the network access layer, the internet layer, the transport layer, and the application layer. The TCP/IP model layers. So the top layer of the TCP/IP layer is the application layer. The application layer combines the functions of the application, presentation, and session layers of the OSI model. This layer provides protocols for end-user services and applications by handling data representation, user interface functions, and session management. Protocols like HTTP, FTP, and SMTP work here by letting users generate data. The next layer that we have is the transport layer. The transport layer focuses on providing end-to-end communication and error correction. Protocols such as TCP and UDP mainly work here to deliver data accurately. The data is segmented and error checking and flow control are applied. Next is the Internet layer. The Internet layer manages logical addressing and routing. The Internet layer applies IP addressing information to segments, converting them into packets. The next layer is the network access layer. This layer handles physical network hardware and MAC addressing. Packets are made into frames, or frames are created to be better transported over a physical medium, such as Wi-Fi or Ethernet. What are the TCP IP model and the OSI model similarities? Well, for starters, both models use an easy-to-understand, layered approach. This allows for isolating and managing different functions of the network, making troubleshooting and communication a lot easier. Both models also help to understand the functions and operations of different protocols and services. Each layer in both models is designed to interact with the layers directly above and below it. What are the TCP IP model and OSI model differences? The OSI model is a theoretical framework design meant for conceptualization. The TCP IP model is generally used for analyzing and designing networks. The OSI model does not specify protocols, but provides a framework for understanding what networks need to operate. The TCP IP model does have defined protocols such as TCP, IP, and UDP, and is the default communication across the internet. The OSI model has 7 layers, while TCP IP has 4. TCP IP combines layers 7, 6, and 5 of the OSI model into the application layer.